Hello, dear friends. So I created this image for chapter electromagnetic induction. Hope so this picture is clear to you. Let me zoom in. Now you can see the topics which we wanna study in this chapter. They are in the form of a emoji. So basically, this chapter is like first we will introduce what is electromagnetic induction. Then we will study. You can see Faraday's law. Then we will switch to magnetic flux. Then we will study about motional EMF. Then we will study about Lenz's law. Then we will be studying about induced EMF. Then we will be talking about inductance and its two types like self-inductance and mutual inductance. And at last, we will be discussing about AC generator. So maybe this picture seems something special to you. So I just add up little bit of creativity so that you are familiar with the topics in a, you can say, unique way. Dear students, now someone can ask you like how you can find the dimensions for inductance. So first of all, you need to know there is a term flux linkage n phi b. N is number of turns in the coil, phi b magnetic flux associated with the coil, and this is proportional to the how much current you are giving to the coil. Now this n represent number of turns in the coil. So we know for any number we don't have any dimensions, like it is a dimensionless m0 l0 t0. So you can see phi b, when I need to change this proportionality into equality, then I introduce a coefficient constant, that is L, and L is nothing. This is inductance. I is the amount of current we are applying to the coil. So from here you can see L will be magnetic flux over current. So magnetic flux, you know, this is VA cos theta over current is I. You know, there are no dimensions for angle, so you can rule this one out. For magnetic field, you can use the formula like F is equals to QVB. So from here you can find the dimensions of magnetic field. The dimensions for the force is M1 L1 T minus 2. This charge will go in the denominator to the left hand side. So I know I is Q over T. So Q will be I into T. For current, we can use ampere to the power 1 or time T to the power 1. For velocity, we can use L1 over T1. This is magnetic field. T1 goes to T1, L1 goes to L1. So you can see For B, we can have the dimensions as M1, L0, T minus 2, A minus 1. For area, this A stands for area, so we can say the dimensions will be L2 because area is always present in like meter square. For current, we will use ampere. So when you do the mathematics, you'll get M1, L2, T minus 2, A minus 2. So this is the easy method to find the dimensions for inductance. As you know, inductance is a ratio for magnetic flux over current. Magnetic flux is, you can see, dot product of two things. So dot product will result in scalar. Electric current is also a scalar. Scalar over scalar, it is a scalar quantity. So this is how you can simplify things. I will suggest you to find dimensions for all the physical quantities you are studying in your class 11th or class 12th. So this is enough for the day. Keep learning.